morning, everyone. Thanks, Aisha, for the introduction. So first off, I'd like to start with a brief background on why these forests are important and why we are studying them. These forests are very important because they provide a home for wildlife habitat. They provide us with natural resources such as lumber and wood products. They aid in carbon sequestration, so they take in carbon dioxide and convert it to oxygen, improving air quality. And they're also very important for water regulation, specifically here in Colorado, for snowpack melt and provisioning it to cities below, such as Boulder. So there's been a global acceleration of tree mortality, and you can see by all of the events are depicted by the red dots. But we're going to be specifically looking at here, this local area, the U.S. Rocky Mountain ecoregion. And this right here is a picture of what subalpine fir trees look like. And the red ones, although they kind of look really cool, they're dead. So that's what a dead tree stem would look like of subalpine fir trees. Our study area is in the Rocky Mountain ecoregion, like I mentioned, depicted by here, the blue. And within that ecoregion, we're looking at subalpine forests. And there's three dominant species of trees. There is Engelmann spruce tree, lodgepole pine trees, and subalpine fir trees. Our focal species is the subalpine fir tree because they've been paid less attention to in tree mortality studies recently. So now, what are killing these trees, or tree-killing agents? We have bark beetles. I'm sure if you're from Colorado, you might have heard of bark beetle outbreaks. And so there's spruce beetle, there's mountain pine beetle, and there's western balsam bark beetle. And this picture here kind of shows what that looks like when a infestation of bark beetle occurs, and they burrow themselves inside of the tree and reproduce and carve out galleries, essentially cutting off nutrients to the tree, not letting it survive. And then there's also pathogens such as armillaria, which is a root fungus, and then just pure drought stress. So severe water deprivation that doesn't allow the tree to survive as well. So ecologically, we have a research question. How subalpine fir mortality is correlated with tree-killing agent factors such as bark beetle and topography across space? We try to answer this using aerial detection surveys from the United States Forest Service from years 1994 to 2015. And essentially what these surveys are is they fly over forested areas annually, and they observe what they see below. So they have a pilot, and then they have the forest observer looking out the side of the airplane, plotting what they see. So it's more of a qualitative study, but it's so widespread. It's a widespread user-informed data set on forests in the United States, so it's useful in that sense. So in order to make sense of this data, or the aerial detection survey data, we use a GIS analysis, or Geographic Information Systems analysis. And so I'll run through the model of this. So like I said, you have the forest observers looking below, observing what they see. And our study regions 1, 2, and 4, those are United States Forest Service regions. They observe real-world data, and they draw polygons or discrete objects in maps or on tablets, and they show what they see, such as lakes, marshes, and what we're worried about is forests. And they provide data on what's going on in that forest, like species, or if there's a stand that's dead or not. And furthermore, in GIS, we convert that into a grid-like layer, or a raster layer, where each grid is a pixel, and each pixel represents 510 meters by 510 meters of forest. And each cell or pixel is assigned a value of percent affected, or percent affected by mortality. So as I said, the nature of the aerial Is that my phone? Sorry. Okay. So as I said, the nature of our aerial detection surveys are very qualitative, and they're very based on the observer and what they see. So in order to kind of mitigate the inaccuracies and improve the accuracies and kind of prove that this is a good way to observe ecological significance, we went through 3 study areas. So we took all the areas that they flew or observed, all the data that they collected from years 1994 to 2015 of mountain pine beetle induced mortality, spruce beetle outbreak mortality, and subalpine fir mortality. And then furthermore, we go to our exclusive study area, which is only areas that they consistently flew and observed every year from 1999 to 2015. And then we go from our exclusive to our focal, which is essentially the exclusive, but focused in on an area that has significant activity of each of the tree-killing agents. So that brings us to our methodological research question. And like I've been mentioning, the nature of the aerial detection survey data. So are ecological correlations affected by the sample areas that we chose of the study, and does that change our ecological significance? So before I go into my results, I'd like to share a quick way on how to understand the results, sort of like a histogram 101. And here we have on the y-axis, subalpine fir mortality, and we'll have our predictor variables on the x-axis. So for theoretical purposes, elevation from low to high intervals. And this particular graph displays that at intermediate elevation intervals, there's high subalpine fir mortality. But for our study, we use histograms, which just simply cuts this x-axis into a much finer scale, creating a smooth histogram. So this is like a 1D histogram. We're going to be looking at 2D histograms, looking at one displaying the presence of subalpine fir mortality and one the absence of subalpine fir mortality in relation to our predictor variable. So these are the 3 types of relationships that we might see in our results. The first one is where the 2 histograms are not necessarily overlapping. So there's a large difference, or there's a large absence of subalpine fir mortality at low elevations, presence at high elevations. Then we could possibly see up here the top right, where both are significantly overlapping, signifying that there's no real relationship of where it's occurring at elevation. And then finally, we see kind of this at the bottom, we see like an intermediate where we have some overlap, but we also see protruding histograms where we can derive an ecological significance, again saying, similar to this, that at low elevations we have absence, and at high elevations we have more presence of subalpine fir mortality. And they'll be depicted throughout the results like that, so you can scan through quickly and see the correlations. So our first row of graphs from A to C is, again, we're looking at them, like I said, methodologically through all of our spatial extents, inclusive, exclusive, and focal. But here we have mountain pine beetle outbreak and how that affects where subalpine fir mortality is occurring. So at the inclusive, or at the broadest extent, we see that mountain pine beetle outbreak. At low mountain pine beetle outbreaks, we see an absence of subalpine fir mortality, while at high mountain pine beetle outbreaks, we see that there's a strong presence. But when you look at the focal extent, or that area where you saw a lot of activity of subalpine fir mortality and mountain pine beetle, there is a high, there is a absence of subalpine fir mortality where there's a high presence of mountain pine beetle. And then we looked furthermore at our spruce beetle outbreaks and how that relates. And you can see that they're pretty consistent throughout all the extents. And you can see that subalpine fir mortality is likely to occur where there is high amounts of spruce beetle outbreaks. Now we go into some abiotic predictor variables, where we're looking at latitude. So at 40 degrees latitude, at the inclusive and exclusive study areas, we see that there's a significant amount of presence of subalpine fir mortality or activity. And that just validates why we chose that our focal area zooms into that particular area. And that just validates why we chose that, because it has a significant activity level. And then we move furthermore to elevation, where we see that at lower elevations there's an absence of subalpine firm mortality, but when you move up higher in elevations, there's more subalpine firm mortality occurring. And then finally, we have slope, where we see that at shallower sites or less slope, we have a presence of subalpine firm mortality, which is characterized as like more moist areas because there's not as much drainage of water. Here we have aspects where 0 and 360 degrees display north-facing slopes, so also characteristically cooler and wetter sites. And you can see again that the plus signs depicting that there is more subalpine firm mortality occurring at these sites or north-facing slopes. And then finally, heat load. So how much heat load is a site being exposed to? And again, you can see that subalpine firm mortality is occurring at the presence of subalpine firm mortality is occurring at heat loads that are less than where the absence is occurring. So areas that have increased heat load exposure are experiencing less subalpine firm mortality, essentially. So now we have our conclusions, 2 sort of methodological conclusions, and then our 2 ecological conclusions. So at the focal scale, we see like our most ecologically meaningful and significant results. From inclusive to exclusive, we didn't see a substantial variance, but that just validates that aerial detection surveys are useful in detecting these kinds of ecological patterns. And ecologically, most subalpine firm mortality is occurring in those characteristically cooler and more wet sites, which is kind of counterintuitive to what you would assume with climate warming. And then the least amount of subalpine firm mortality is occurring in drought-stressed sites. So the implications in future work for this study, it's important to know that indirect effects of warming climate are just as important as the direct effects of warming climate. As I mentioned, the cooler and wetter sites are the ones that are displaying to be more significantly affected by warming climate. So we think possibly exposing these cooler and wetter sites to new kind of conditions are making it susceptible for biotic attacks to kind of take away. And then future works are just linking this very large broad-scale analysis to individual tree stands and linking it to actual climate data. So I'd like to thank my research mentor, Brian Harvey, my communications mentor, Kelly, the NAVCO, of course, RESESS, and the National Science Foundation, making all of this research possible. So I'd like to open the floor up to any questions.
All right, questions for Allie?
Have you taken much look at how the subalpine fir trees are distributed, as to whether there's more of them at low elevations versus high elevations, and would that affect your correlations?
Yeah, so essentially what we're looking at is where subalpine fir mortality is occurring. So we're looking at subalpine forests where they occur. So the study area is where they are occurring.
So you're looking at predominantly alpine forests.
Right, only alpine forests.
Okay, and another question is, have you looked at a correlation between the 2 different kinds of beetles? I forget what they were. The
mountain pine beetle and spruce beetle?
Yeah, mountain pine and spruce beetle. Do they like correlate, or do they interfere with each other?
Yeah, so in previous studies, it's kind of been seen that mountain pine beetle and spruce beetle don't really occur in the same areas. In relation to subalpine fir mortality, we were seeing that spruce beetle was kind of occurring concurrently with subalpine fir mortality, and mountain pine beetle, it wasn't occurring like at the high activity levels. Did that answer your question?
Yeah, I was just wondering if the beetles would compete with each other. So.
Oh, okay. Yeah, not necessarily.
Thanks. Thanks, Christine. Oh.
Can you go back to your slides with the last graphs before you started the kind of conclusions? That one there. Yep. So in the D, E, and F. So were you saying that there was more beetle kill in the north-facing aspects? Is that what you were saying?
Yes.
I guess that would seem confusing. We would have thought if that was cooler and wetter, why wouldn't the trees be doing better than the south aspects where it's hotter and drier?
Right. So the south aspects, where it's kind of getting more exposed to heat, forests aren't as dense, and they're more drought stressed. So what we think is bark beetles really take away where there's dense forest, and a warming climate might be inducing drought stress in those sites that would not typically have the conditions or would be too cold for bark beetles, but now is kind of having those conditions where bark beetles can take place, such as like a warmer climate, and causing outbreak on those cooler sites where there's a dense population of trees that are larger, and so previously they weren't susceptible to bark beetles, but now they are, and so the bark beetles are outbreaking.
Okay, thanks.
Thanks, Mike. Any other questions? Nope. All right, thanks, Allie.
Yeah.